Hi, this is our first video in Unit 3, Atomic Structure. And I would like you to have your guided notes out so that you're following along and filling in your guided notes. So this is on ions and isotopes. So back in our first unit, we defined an element as something that was made of one kind of atom. But what makes one element different from another element? Well, it has to do with the subatomic particles. So as a review, the subatomic particles are the protons. They're located in the nucleus and they have a positive charge. Neutrons are also in the nucleus, but they have no charge, so they're neutral. And the electrons, well, they're somewhere outside of the nucleus and they have a negative charge. So what makes each element unique? Well, atoms of each element have a characteristic number of protons in the nucleus. So it is the protons that make each element unique. And the number of protons is given by the atomic number. Some textbooks just call it a Z, but I'm not going to use that. It's called the atomic number, and it's the number of protons in the nucleus. It identifies the atom. It's above the element symbol on the periodic table. So if we had helium in the periodic table, see that 2 above the helium? That's the atomic number. The atomic symbol is, as we've learned before, a capital letter, and if it's a 2-letter designation, the second letter is in lowercase. In this video, we're not going to talk about the atomic mass. Well, atoms are neutral, which means they have no charge. So the positives and the negatives must be equal. So the number of our protons must equal our number of our electrons. So if our atomic number is 2, and that's the number of protons, in an atom, that would be our number of electrons as well. Here's a really colorful periodic table, and as you can see, as you go across the periodic table from left to right, the atomic number goes up by 1. So hydrogen's atomic number is 1, helium is 2, the atomic number for lithium is 3, and so forth. And that atomic number is just telling you, hey, that is how many protons are in the nucleus. And if I'm a neutral atom, it's a number of electrons as well. So I would like you to fill this chart out in your guided notes. So potassium, look for it on your periodic table. What's its atomic number? Did you find the 19? If the atomic number is 19, that's the number of protons. If we're talking about an element that is neutral, that is also its number of electrons. Fill in the rest of your chart for sodium and lead and tin and carbon. Look on the periodic table. Find the atomic number. Write it down. And that is your number of protons. We're talking about neutral atoms here, so that will equal your number of electrons as well. Well, how do we remember this? Well, Mr. Grundon told me to remember APE. APE. A stands for the atomic number is equal to the protons, which is equal to the electrons. APE. Now, what about ions? Well, first of all, what are ions? Ions have a charge, so they could be positive or they could be negative. So our electrons do not equal the number of protons anymore. What happened? Well, atoms can gain or lose electrons, and now they have a charge. Remember, those electrons are outside the nucleus, and they're kind of easy to lose and to gain, but that's for another day. Well, the way I remember that a positive ion is called a cation is with this picture of a cat. So a cation has a positive charge. Well, how did it get that positive charge? It lost electrons. So if we have a sodium atom, it will have 11 protons. We got that from the atomic number. It'll have 11 electrons if it's an atom because it's neutral, and our protons and electrons will be equal to one another. Remember the ape. But now we've got an ion of sodium, and the ion's charge is shown as a superscript. And so do you see that plus sign? So sodium, and then the plus sign means it has a +1 charge. Oh, it's an ion. It's not neutral. Well, it's sodium, so the number of protons cannot have changed from what it was before. We still have 11 protons. But we lost an electron because it has a +1 charge. So now we only have 10 electrons. Notice we have one more positive particle than we have negative, and that's how it got its positive charge. We lost an electron. Metals tend to form cations. They like to lose electrons. So if we look at the potassium atom with 19 protons and 19 electrons, if we look at the ion with that +1 charge, it lost an electron. Now, they can lose more than one. Let's look at iron. The iron atom has 26 protons and 26 electrons, but it can form a cation with a +3 charge. Well, that means it still has 26 protons, but it lost 3 electrons. That's why it has a +3 charge. So we don't have 26 electrons now, we have 23 electrons. And again, look at what happens with calcium. If calcium forms an ion with a +2 charge, we still have 20 protons because that's its atomic number. But that +2 charge, we've lost 2 electrons. So we don't have 20 electrons, we have 18. And here's a little cartoon. It's the War of the Atoms. You may have seen it before. One atom says, I'm hit, I've lost an electron. The other atom says, are you sure? And he says, I'm positive. Atoms that lose electrons form a positive ion, and we call them cations. We can also have negative ions, and they're called anions. They've gained electrons. Nonmetals tend to form anions. Well, let's look at a chlorine atom. It's a nonmetal. Has 17 protons. That's its atomic number. If it's an atom and it's neutral, the electrons will equal the number of protons, 17 electrons. But now let's look at a chlorine with a -1 charge. It's now called the chloride ion. Notice the ending changed. It's not chlorine, it's chloride. We give it the "ide" ending when we add some electrons to it. Well, it still has 17 protons, but the chloride anion has gained an electron, so it has 18 electrons. And that extra electron gave it a negative charge. We can do it with the oxygen atom. 8 protons, 8 electrons matches the atomic number, but the oxide, see that ending again, the anion has that "ide" ending. The oxide ion has a -2 charge. Well, the protons is the same as the atom, 8 protons. The number of electrons, however, we've gained 2 electrons, and that's why it has the -2 charge. So we have 10 electrons. Now, we haven't talked at all about neutrons. They're neutral. They don't have any charge. They're in the nucleus with the protons. They have about the same mass as a proton. Actually, the protons and the neutrons are pretty much all the mass of an atom. They're 1,900 times, approximately, heavier than an electron. We don't even count the mass of an electron in an atom. So let's talk about what we call a mass number. Some textbooks call it capital A. Well, a mass number is the sum of our protons and our neutrons in the nucleus. They're the 2 particles that have mass. We'll add them together, and that's our mass number. Now be careful. The mass number is not the atomic mass that's displayed on the periodic table. We're going to talk about how we get that number in a later video. So, Going along with the ape theme, now we've got a man theme. Man, the mass number is equal to the atomic number, that's our number of protons, plus our neutrons. Again, our mass number is our number of protons plus neutrons. So let's practice. If we have a carbon atom with a mass number of 12, well, look on the periodic table, carbon has an atomic number of 6. 6 protons. We're back to talking about atoms now, where the electrons are equal to the number of protons, 6 electrons. If the mass number is 12, let's remember our man. Our mass number is 12, and that's equal to our atomic number, 6, plus, well, however many neutrons we have. Doing this simple algebra, x is 6, we have 6 neutrons. Let's try some more. Phosphorus atom has a mass number of 31. Well, according to ape, we have 15 protons. Look at the atomic number on your periodic table. That equals our number of electrons, because we're talking about a neutral atom. Now, what about our number of neutrons? That's where the man comes in. Well, our mass number was 31, and it's equal to our atomic number 15 plus however many neutrons we have. So I made it an x. When I solve for x, I get 16. Phosphorus 31 has 16 neutrons. Wait, here's another phosphorus with a mass number of 32. Let's go ahead and figure out how many neutrons it has. If we do all that math again, we're going to find out that this phosphorus has a heavier mass number, 32, has 17 neutrons. What's the deal? 2 different kinds of phosphorus? Well, yes, they're called isotopes of one another. An isotope, I really want you to know what this is. It is atoms that have the same number of protons, but they differ in their number of neutrons. They have the same atomic number, but a different mass number. Well, how do we display this? All right, there's 2 different ways we can use. First of all, we can use our symbol from the periodic table. So we'll use phosphorus, capital P. And to the left of it, we've got this superscript 32. That's the mass number of this particular isotope. And then down below it is a subscript with the atomic number. That's one way that we can display the atomic number and the mass number. Another way is just to put the symbol and a dash with the mass number. Here we're not displaying the atomic number, but if it's phosphorus, all we have to do is go to the periodic table and find out that it's number 15. So these are 2 ways that we display our atomic number and our mass number. So in summary, this video has taught you how to figure out how many protons, electrons, and neutrons are in an atom or an ion, and we learned what isotopes are. Just remember the ape man. Atomic number is equal to the number of protons, which is equal to the number of electrons when we have an atom. Man, well, the mass number is equal to the atomic number plus the number of neutrons.